Okay guys, so in this video I'm just going to briefly go over some of the solutions to the study guide. I'm not going to go over everything, but some of it. So let's begin with the first diagram that I gave you. I'll give you these first three and I'll explain supplementary angles as well. Nah, I'll just give you the first three. Alright, so let's begin. The first set of angles that are given here, well, the first set of angles will be these two, angle AHF. And here's AHF. That would be this angle right here. Angle AHF would be this one. Then it's telling us that it's congruent, that it's the same as angle GHB. GHMB. So these two angles looking like this angle on the right and this angle on the left, they're the same, they're congruent. Now the question is, why are they congruent? What's the reason? What's the reason that they are congruent? And well, anytime that we have angles that look like this, we know they are congruent because they are vertical angles. So notice they're just across each other. They're opposite to each other. Those are vertical angles. Then the next set of angles that we have will be these two angles right here. Which would be the first one, it's AHG, so AHG. That would be this big angle right here, angle AHG. And the other angle is DGH. So D, G, and H, that would be this angle right here. So let's take a look at these angles. Now, they're not across each other anymore. We know they are interior angles, and this one right here is on the right side, and this one right here is on the left. So these would be called alternate interior because they're inside. So alternate interior angles. All right, now the next set of angles that we have, let's see, which are they? Would be these angles right here. And that would be angle FHB. So FHMB. That would be this angle right here. So this angle is angle FHB. And the other angle is CGE. So C, G, and then E. So what would be the angle outside right here? CGE would be this angle. All right, so now we have this angle right here, which is on the left side, and this angle right here, which is on the right side. And they are both on the exterior. They're both on the outside. So these angles are alternate exterior angles. Angels. Alternate exterior angles. And this is some of them. The next one will be supplementary, and just remember that two angles will add up to 180 if they are supplementary. You can look at a lot of examples in this diagram of angles that are 180. You can take for instance the purple angle right here and the red angle right here, and these two angles, this purple and this red one, would be supplementary angles. You can take the green and the red, and they would be supplementary angles. You can take this red one again and this purple again, the red and the purple, and these two would be also supplementary. So they just have to make up a straight line in either direction. All right, so that would be for supplementary. And then alternate interior, alternate exterior. There are another two sets. Well, another set of alternate interior and another set of alternate exterior. You have to look for them. All right, now the proofs. This is part of where things become a little more complicated. So in all of these problems, all of them, your main objective, your main goal is is to prove that all of these triangles that I'm giving you are the same. That is, bottom line, one of the most important things to be able to do. Prove that the triangles are the same. And I have triangles for all of these problems. You have to prove these triangles are the same. All right. And again, we have four different, well, five, but technically we'll just be looking at four. Okay. We have the side angle side, the side side side, the angle side angle, and the angle angle side. We also have HL, but we're not going to use HL in these problems. Okay. But these were like the main four that we'll be using to prove two triangles are the same. In all of these problems, we want to prove the triangles are the same. Well, the first question is asking, it's actually telling us to prove the triangle NOP is congruent to triangle NQP. So let's go ahead and prove that these two triangles are congruent. All right, so let's begin to do that. First of all, I want to point out the given statements. This side right here is congruent to this side right here. That's a given statement. This side right here is congruent to this side right here. That's another given statement. So I want to make sure that I have these two given statements written on my proof. All right, so let's write the first given statement. So the orange one, that would be segment NO. Segment NO would be congruent to segment NQ. And the reason for this, it's because it's a given statement. Then the second one, the red ones, that would be, I'm just going to copy and paste this. The second statement, that would be segment OP, would be congruent to segment QP. And the reason for this, it's because it's also a given statement. They gave it to us with the tick marks. They're given to us, so they are called given statements. So far we have two things, and it just happens that these two things relate to segments. So the orange ones gave us a segment, the red ones gave us a segment. All right, now the other one, the last one, will typically be hidden somewhere. We just have to look for it. We just have to recognize the different things that are given to us. In this case, as you guys notice, there's no vertical angles, there's no alternate interior, there's no alternate exterior, but we have two triangles that are sharing a side. And because they're sharing a side, it means that this side right here, NP, is congruent to itself. So that would be the next statement, that these two sides, this side NP is congruent to itself. So NP is congruent to NP. And whenever a side length is equivalent to itself, that is called a reflexive property. All right, so we have everything we need to prove these two triangles are the same. And in this case, as you guys can notice, all of the three sides of both triangles are the same. So these two triangles are congruent by the statement is that these two triangles are congruent. So triangle NOP is congruent to triangle NQP. They are congruent. That is what I want to prove. We have shown that is true. They are congruent, and the reason for that, it's because of the side triangle congruence theorem. And we are done. We have proved that these two triangles are in fact congruent, and the reason for that, it's because of the side triangle congruence theorem. And that's it. Number one, it's the easiest one, because it's just asking you to prove that triangles are congruent. Now, that doesn't make the other ones a lot harder, okay, but it just gives us another step to consider. For this one, they're asking us to prove that JK is congruent to LM. So JK is this side length over here on the left, and MLM or ML is this side length over here on the right. We have no markings. We don't know that they are congruent. They may seem like they're congruent, but we don't know anything about them yet. We have a few given statements right here. First of all, I know that this angle right here is congruent to this angle right here. That's a given statement because I see the markings. I know that this angle right here is congruent to this angle right here. That's another given statement because I can see the markings. And finally, similar to this one, both of these triangles are sharing a side. So this side is congruent to itself. And right there, pretty much I have everything I need to show that these two triangles are congruent. And you may be wondering, well, but the question is not asking us to prove the triangles are congruent. But I'll show you what happens once you prove that they're congruent. So let's first list all of these things down. Okay, so let's begin with the red ones. So angle, let me look for the angle symbol. So angle KJM, that would be the red one on the far left. KJM would be congruent. The congruent symbol would be congruent to angle MLK. MLK. All right, so that would be the two red ones. Okay, both of those angles, both of those red angles are congruent. Now the other one is the orange one. So the orange one, this one on the far right, that would be angle JMK. So that's this orange one. And that angle is congruent to this other orange one, which the name of it is LKM. So these two are congruent. So far, that's the red ones and the orange ones, and those are given to us. All right, and then finally the green one. So that's going to be like this one. So the green one, the name of the green one is KM. It's congruent to KM. So there you go. Segment KM is congruent to segment KM. And this is true because of the reflexive property. All right, so given this, now I can tell that these two triangles are congruent. And the reason for them to be congruent is because of the angle side. They're congruent because of the angle side triangle congruence theorem. All right, so now those two triangles are congruent. Okay, so the name of the first triangle, the name of this triangle on the left would be KJM. KJM. And the triangle on the bottom would be KLM. So these two triangles are congruent. Why are they congruent? Well, they are congruent because of the angle side triangle congruence theorem. But that's not it. Oh, and look at this. I actually gave you guys an extra line. Sorry, this is not supposed to be there. Entire row. Okay, they are congruent. The two triangles are congruent. All right, so now I know both of these triangles are congruent. If two triangles are congruent, then all of their corresponding sides and their corresponding angles are also congruent. And well, this side length over here is corresponding to this side length over here. that means that Kj is congruent to ML or LM. So that would be this statement right here. Once I know the two triangles are congruent, therefore their corresponding parts will also be congruent. That's why I want to prove that these two triangles are congruent. So that would be the proof. There you go. JK is congruent to LM. And the reason for them, it's because corresponding parts of congruent triangles are congruent, or CPCTC. And that's technically what you want to do. All right. Now, I'm just going to explain the next one verbally so that this video doesn't drag on longer than what already is. Okay. But again, you can see given statement right there, given statement right there, another given statement right there, another given statement right there, and notice we have vertical angles. Angle, side, angle. Triangle congruence theorem. Therefore, these two triangles are congruent because of the angle, side, angle, triangle congruence theorem. And we're going to be using CPCTC again because we want to show that segment AC, which would be this segment right here, congruent to DC, which would be this segment right here. Well, these two segments, AC and DC, are corresponding parts. And we know that corresponding parts of congruent triangles are congruent. Okay? But this statement, this last statement, okay, which is this one, this last statement, we can only make it once we have shown that the triangles are congruent. Okay, so you want to take this last statement and write it right here in the end once you have shown that the triangles are congruent. And I think I kind of did the same thing from the rest, from the other one. Okay. And that would be it. That would be proof number 3. Something like that. All right, in this one, we're going to show something else. So let's see. Prove that point I, so this will be this point right here, bisect segment FH. FH. It may seem something completely different, but it's not. To prove that something has been bisected, you have to show that the two halves of the segment that is being bisected are congruent. If you are able to show that both halves are the same, therefore the segment has been bisected. And technically right here we want to show that this half is the same as this half. If I can show that this side Fi is congruent to this side IH, then I would have shown that point I, this point, is bisecting, cutting in half, segment FH. That is all I want to do. So let's see. How would this look? Well, pretty much I want to start making the list of my given statements. I know this angle right here is congruent to this angle right here. That's a given statement. I know this angle right here is congruent to this angle right here. That's another given statement. And notice both of these triangles are sharing a side. So that means this side in the middle is congruent to itself. So we get an S out of this, an S out of this. Oh, sorry, not S's. These are not sides. These are angles. Okay, these are angles. I'm sorry. We get an A out of this, an A out of this, and from this one we're gonna get the S. So these two triangles would be congruent because of the angle, angle, side, triangle congruence theorem. Therefore, this side right here in the middle would be congruent to this side right here in the middle. Right, so that would be Fi would be congruent to IH. And the reason for that, it's because those sides are corresponding sides. And we know that corresponding sides, corresponding parts of congruent triangles are congruent. And so, because these two sides are congruent, therefore, my last statement would be that point I bisects FH. Why? Well, because of the definition of bisected segments. And that would be it. Again, I don't know. It seems like I gave you an extra thing every time. All right, that would be that one. And finally, number 5. Let's see, what is number 5? So given that CD and AB are parallel, so CD, that would be this segment up here. So this segment and this segment are parallel. Nice, we know they are parallel. Okay, so CD and AB are parallel. And look, this right here, it's a given statement because these two angles are congruent. That is definitely a given statement. They're asking us to prove that angle CAB, let's identify where is angle CAB. So CAB, that would be this angle, would be congruent to CDB. CDB, that would be this angle. We want to show that this angle right here is congruent to this angle right here. That is what we want to show. If you notice, these two angles are inside of these two triangles. This triangle right here and this triangle right here. So we want to show that, well, pretty much, as you can tell from all of this process and all of this repetition, you want to show that these two triangles are the same. So therefore, because these two angles are corresponding angles, therefore they will also be the same. So what do I want to show here? The exact same thing. Let's prove these two triangles are congruent. So let's begin and do that. So far, I only have, out of these two triangles, I have that this angle is congruent to that angle because that's a given statement. But then if you notice right here in the middle, these two triangles are sharing a side. So that means that this side is congruent to itself. That is good. That is great so far. Now, from here, I want to be strategic, okay? I don't know what else I could get, but there's so many things that I could get out of this, okay? First of all, because these two segments right here, this one and this one, the ones that I'm pointing to in green and red, these two segments, these two lines are parallel. That means that this line right here could be treated as a transversal line. This one could also be treated as a transversal one. This one could also be treated as a transversal one. All of these could be treated as transversal lines. Now, I don't know which one would be the best one to use, but here's the thing. I have side, angle, side, angle, side, 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 and angle, angle, side. One of those four I want to use to prove that these two triangles are the same. Would it be nice if I got that this angle was the same as this angle? If I'm able to show that these two angles are the same, notice I would get angle, side, angle. It would be nice if I could show that these two are the same. Therefore, I could use angle, side, angle, triangle congruence theorem. And technically, that is the best option. That is what I want to show. It would be great if I can show that those two angles, again, this one and this one, are the same. Let's do that. Okay, you could try to do other things. Maybe you don't like side, angle, side a lot. Maybe you want angle, angle, side better. If you wanted to show angle, angle, side, then you would have to show this angle and this angle. So you would get angle, then side. This could also work as well. The thing is that it doesn't. Because if you notice, this angle right here would belong to this line right here, to this transversal. And this angle right here would belong to this other transversal. So for this to actually work, we would actually need to know that these two lines are parallel. But we don't know that they are parallel. Only this one's going like this, they're parallel. But we don't know anything about these ones going down. So yeah, bottom line, my best option in this case is going to be to show that this angle and this angle are congruent. So let's do that, okay? And to do that, I want you guys to consider segment CB. I want you guys to consider segment CB, which is this whole segment right here. I want you guys to consider segment CV as a transversal line. And notice, if this segment CB is a transversal line, then this interior angle would be congruent to this interior angle. So then this angle right here, DCB, is congruent to ABC. So these two green angles are the same. And the reason for them to be the same, I have to give the reason for why they are the same. Well, the reason for them that they are the same, it's because they are alternate interior angles. If you notice, they are inside. One of them, this one is on the left, and this one is on the right. And so, there you go. This triangle right here is congruent to this triangle right here because of the angle, side angle, triangle congruence theorem. And because these two triangles are congruent, therefore their corresponding parts will also be congruent. And this part right here is corresponding to this part right here. Therefore, angle CAB will be congruent to CDB because of corresponding parts of congruent triangles are congruent. And that would be your last statement, okay? So in terms of reasons, you will have a given. We had the reflexive property. And we had the alternate interior angles. And of course, right here we got the angle side angle triangle congruence theorem. And that would be it for the last proof. Okay. So hope this video helps. It has a lot, I know. Use it to study for tomorrow's quiz.